presentation is possibly the first time in the country, or maybe the first time in the world. So I would only say that deep learning has like come up in the last 10 years. Like I remember as a postdoctoral researcher, I was looking into deep learning, and that time there were no toolboxes available. So in fact, I still remember that MatConvNet was the first toolbox by Andrea Vedaldi at Oxford. So he was the first person to have a decent toolbox on deep learning. That time MATLAB did not have any toolbox on deep learning, nothing. So Aparna, when she started, she was absolutely new to the area of deep learning. Also, I was new. And so I will show you some work which is done with in those times when you did not have today's TensorFlow or Keras or PyTorch. All those things were not there. Only very recently, after 3-4 years, once Aparna was about to graduate, these things started coming in, and we started experimenting with these things, and slowly we built some work. And the main crux of this work is that, let me start the presentation. This is the title of my presentation. So let me share my screen. I can share screen here, right?
Yes, sir. There is an option share screen.
I generally don't use Zoom, so just forgive my awkwardness. Can you see my screen, everyone?
Yes, it's all visible.
Okay. So can I do a full screen? Will you be able to see the full screen? I don't know whether this will go in full screen mode or not.
No, it is not in full screen. It is still split mode.
Is it in full screen, Srija?
No, sir. It is still in split mode.
Okay, wait. Let me try. Yeah, is it now in full screen?
Yeah, yes, it's visible. Yes.
Okay. So this is the title of the talk. So Aparna had done something on understanding Indian classical dance. So this topic itself is a very adventurous topic. Not many researchers get into this area. I have not seen many papers by many researchers in this area. Although there are papers which exist in the Western world trying to understand dance from the point of view of action recognition, from the point of view of body pose analysis. So you can spot some papers, but hardly very few papers on Indian classical dance. And when we started this work, we were like making baby steps in the area of deep learning. So some of our networks that you will see here, they are very, very simple and very basic networks. Although the problem that we are addressing, that is a very rich problem. And it is a video understanding problem. It's a problem where you are looking at real world scenarios where you are trying to interpret dance. Like one of our papers talks about unveiling the intent of the dancer. Okay, so we had one paper in our in ICVGIP, if you know ICVGIP conference. I got invited into a book chapter which was titled to understand the intent of the performer, which is a very hard problem to address. So with that motivation, let me begin this talk. So the talk is titled Nrityadarpan. So Darpan, you know, is a mirror. Okay, so you are trying to understand the reflection of the dancer on your mind. That is the thing which I want to suggest by titling this talk as Nrityadarpan, where computer vision and deep learning, they meet Indian classical dance. So we have techniques from computer vision, we have mathematical intricacies of computer vision, and we have the deep learning, machine learning tools to try to make sense of what is happening on the stage. So if I just digress a little bit, I was a student at IIT Madras, and just next to IIT Madras in Adyar, there used to be what is called Kala Kshetra, How many of you have visited Kalakshetra? Have you ever gone and seen a concert there? Maybe a Bharatnatyam concert or something. So it is a wonderful auditorium, fully made of wood, a wooden auditorium. I never saw something like that. So it was established by Dr. Rukmani Arundel in the times of during the times of early independence, and they train dancers on Bharatnatyam and maybe all other kinds of classical dances. So I just went there with my friend and watched some concerts, and I used to wonder, like, can I do something with computer vision one day to understand what the dancer is trying to say or trying to enact. So I could never fully understand what is going on. So I used to have a difficulty in understanding the language, and also, of course, the language used to be Sanskrit. So difficulty in understanding what is being spoken, what is being enacted, and there are so many other problems which I will show you. So, what is the motivation for this work? What will be the thing that we have done? What is the proposed method, and what are the tools that we have used? Some ideas about future, and I'll show you some references which you can use if you want to work in this area. So let me begin with this shloka, which actually Aparna uses in all her presentations. So I will show you this. And because why I'm trying to show you this is that there is a word here called mudra. Okay. This word mudra is a very, very deep word. Those of you who would have visited the international airport, Delhi International Airport, T3, you would have seen sculptures of Hasta Mudras on the wall. Have you ever seen those? Have you marked that thing if you visited T3? Anyone? Have you taken a flight from Delhi or gone to Delhi? So you would see that there are a set of bronze sculptures on the wall, and huge sculptures of what is called Hasta Mudras. So the first work that I'm going to show you is something to understand how or to recognize Hasta Mudras, to interpret what is being enacted by the dancer on the stage. So let me straight away jump into the presentation. So you see, like, we as human beings, or rather, let me say about primates or even animals like dogs, most of the communication in in the in the living world is non-verbal in nature. Okay, so just yesterday I was watching a program on the German TV and the German TV channel. So I saw that they are talking about octopus as sentient beings. That means they are now recognizing that octopus have emotions, and that is really amazing. And octopus respond to emotions. Some of you would know that people had used an octopus to predict the result of the World Cup, the football World Cup. So, in the animal world, the communication between individuals is non-verbal to a large extent, and in humans also. Although we use speech, which is the most advanced form of communication, still we use a lot of non-verbal communication. And non-verbal communication is predominantly used in performances of dance and theater. For example, in opera, in mime performances, you would have participated in mime performances or mime acts as a student in many like spring fests and things like that, where you are not allowed to use words but just enact things out. And there is something called the Japanese kabuki theater. Again, if you get a chance to watch this, you can see that uh, how sophisticated uh, are the non-verbal communications there. So in Indian classical dance, we observed that it's a blend of various things. For example, there are some things called karanas or body postures. So those, you are in South India, Chittur, Nellore. Have you ever visited Chidambara, the temple in Chidambara? So on the temple there in Chidambaram has sculptures about 108 or more than that body poses or karanas, which are used in Indian classical dance. So I'll try to show you some videos here where I'll point out these things to you. Then we have hand gestures, both single hand, double hand. Okay, so Asanyukta Hasta Mudras, that means single hand, and Sanyukta Hasta Mudras, that is double hand gestures. We have facial expressions. In English, we use the word facial expression or emotion. In Sanskrit, we use the word navarasas. The rasa is much deeper than emotion. Okay, so I hope that there are people in the audience who understand what I'm trying to say. I am not an expert on dance, but I have at least understood that it is not only emotion. Rasa is much deeper than emotion, and it is subtly it is exploited in dance to convey very sophisticated, high-level thoughts. So we'll see. Then, how does a dancer convey all this? So she moves her hands, she enacts a particular pose, uh, enacts a rasa by moving the neck and the eyes. Okay, so those who have ever observed or have you seen a performance in Kathakali, you would understand what I mean exactly. So in Kathakali, body movements are limited, but the upper body movements are really important. So there are neck movements and there are eye movements in which people exploit these things to tell you a tale from mythology. For example, something from Mahabharata or from the Ramayana. And believe me, our culture, it extends over huge areas or expanse of land, like right from Afghanistan to Bali and Indonesia. And in fact, you can see, uh, I would refer you to one particular reference. Uh, I forget the name of that lady, but she was the first person or the first dancer who had researched this area, and she had found that there are temples in Java and Sumatra where they had enacted the poses or the body poses of Indian classical dance. So, so these things I have shown in the papers that we wrote with Aparna, and like you can refer to those papers and you can see those who are more interested to learn about this. So, what do we want to do in this work? So, we want to understand what the dancer is trying to enact from short videos. That means we are limiting ourselves to just enactments of shlokas or very short videos. I'll try to show some example videos in which the dancer is conveying some meaning that is being told in the shloka by use of hand gestures, body poses, and emotions and rasas. So these are, can you see my cursor? This is a karana. Okay, it's a static karana. Now there are things called adabus. Those who know Bharatanatyam dance or have been exposed to Bharatanatyam dance, there are multiple sets of adabus, which are a sequence of body postures. So the dancer enacts a certain set of body postures. So over a certain temporal set, you can say that the entire thing is a fixed pattern, is a dynamic pattern. So we are in the business of pattern recognition, whether they are static patterns or whether they are dynamic patterns. So we looked at static gestures, we looked at dynamic gestures, we looked at static body poses, we looked at dynamic body poses. So static body poses are called karanas, dynamic body poses are called adabus. We mainly looked at Bharatanatyam, although we explored from the YouTube and from other sources, other dances also, like for example Odissi or Kathakali or other dance forms. And you'll see, I've just shown a snapshot of 9 rasas which are there in all Indian classical dances. All Indian classical dance, they trace their origin from Bharat Muni's treatise on dance. So so you can see that all of them have the same navarasas. So we'll see in deep detail how we proceeded further. So some of the challenges that we faced while processing the data. Both we work with actually real data and also with lab data. That means data captured in the lab. So if you see the dance performance, a real dance performance, it is an aesthetic experience. It is not something that is done in normal lighting conditions. Sound and light, they combine to form a magical ambience, an ambience in which you see the person is, he rises from a human being to something else. He transcends. Okay, the dancer transcends his physical existence into something else. It becomes a concept. Okay, so the dance is a real good dance performance will elevate you. Okay, so how is that achieved? It is achieved by a blend or a consonance of music, lighting, and and I don't know, like something which I cannot describe in words. Okay, so initially when we started to process these videos, we faced huge difficulties with these kind of lighting. Okay, then we used to find that sometimes the enactments of these body postures or karanas are non-frontal. That means the camera is placed in such a place that it is not getting you the correct viewpoint that your machine learning algorithm can classify correctly. And there can be large distance between the camera and the person. So you get difficulties in learning or doing the pattern classification. So spatial resolution, then you have makeup and costume of the dancer. Okay, so that can vary drastically. So for one particular costume, one particular ambience, you can maybe tune your machine learning algorithm, which will fail for another dancer. So how do you make sure that it generalizes well? How do you make sure that your algorithms, they generalize? That is one major challenge that we faced. So initially, the work that Aparna did was she started capturing data sets. So she has captured a huge amount of data sets. She has done a lot of work, and in fact, like all our lab members, they have contributed this to this work. And maybe sometimes you can spot some of our lab members. Dr. Srija here, she knows many of our lab people, so maybe she will spot some people here. So you see, like we talked about hand gesture recognition. So we have single hand gestures here. There are some of the single hand gestures used in Indian classical dance I'm showing here. And there are Sanyukta Hastamudras. That means hand gestures enacted by using both hands. And each of them have their importance. If you see this particular hand gesture, if you are able to see my cursor, it's called a Matsya hand gesture. Okay. This Matsya hand gesture may be static, may be dynamic. So you can imagine that somebody is holding his hand like that and is moving his fingers like that. Okay. So that is a dynamic hand gesture. So we initially worked with static hand gestures. We did not work with dynamic hand gestures. But although we have later on done some work in that area also. Now, this was lab data, whatever I just showed you. Background is very well controlled. So you see, we have blanked out the background by putting a black curtain. Okay. Spatial resolution is good. Lighting is uniform. We have ensured that lighting is proper, and we have captured good resolution pictures. Now, what happens if the background changes or you have something on the foreground? That means you have makeup of the dancer. So generally, Indian dancers, they use either mehendi or they use some red color on their hands. And you can see that fingers are colored, nails are colored. Sometimes the palms are also colored. So how do you make your algorithm agnostic to all this color? Sometimes there is jewelry on the hands. So there can be rings, there can be bangles. So what do you do to make your algorithms robust? So that is what we are trying to understand. So some data we have taken from the YouTube, and some of it we captured like using professional dancers. So we'll slowly see like how data was collected. And as I said, we were taking baby steps in deep learning at that time. So we had Lenet. Lenet 5, Lenet 7, proposed by Jan LeCun. So we used just 2 convolutional layers and we achieved good accuracies on our datasets. So if you see, the image size is only 32 cross 32 pixels. Okay, small sized hands. So here the accuracies are very good. Okay, and with random initialization of weights. So with random initialization of weights, you see like the number of epochs will be large, and the toolbox used is MatConvNet. So those of you who are familiar with MatConvNet, you would immediately recognize that this was one of the first toolboxes in the area of deep learning. So we at that time were also experimenting with what is called transfer learning. So nowadays you call that as pre-training. So we earlier started with random initial weights of the CNNs. Then we pre-trained the CNN using some data sets. So we have used CIFAR dataset, and then we have pre-trained it, and then we saw that the number of epochs necessary, they fall drastically. So, and the accuracies remain high. So some of these things, like they are initial like explorations in deep learning. Today it is standard, but in those days it was not standard. So the first thing that I will like to show you is this small video by a dancer called Manju Warrior. So she was performing um, in a small concert, and I would like to show you that entire video. So this is the first shloka that Aparna had tried to locate on YouTube. So this is real world dance, and I'll just show you the video. For some time I'll play the video and then I'll come back to what we can do with the video and how do we try to understand the video. I hope you are able to see the video and hear it.
Yes, sir. Yes.
Please pay attention to the hands. So you see, there are so many challenges in this video. First of all, the dancer is not frontal. The camera is placed at a bad viewpoint. So the dancer is being seen from a tilted angle. That means from a non-frontal position. So if it is like that, then how do you look at the hand gestures? Now there are so many hand gestures that were enacted. So I'll show you a small table where you can see that initially the dancer is trying to enact the word Gurur Brahma using 2 hand gestures. Then there is another hand gesture, Shankha. Then there is a hand gesture, Chakra. Okay. Then there are some standard hand gestures called Pataka. Then this hand gesture is typical to denote what is the Shivalinga. So the Shivalinga is associated with Bhagwan Maheshwara. So we have this particular hand gesture. And then again, Pataka hand gestures. And then the Anjali. So sometimes the hand gestures are frontal, sometimes they are non-frontal. They're taken from a side. So how do you make a robust algorithm to identify these hand gestures? And by identifying these hand gestures, can you correlate the hand gesture with the words spoken in the shloka? So that is what I was trying to show you here, that we have manually segmented out all the frames. Okay, so there is no automatic segmentation, nothing. So manually segmented the frames where the shlokas, where the hand gestures were there, and we try to correlate the hand gesture with the words in the shloka. So these words are being correlated with the hand gestures. Okay, so that is the way we try to understand what is being done on the stage. So this is just first piece of work of Aparna, and this is I think this paper was Nritya Bodha, sent to signal processing image communication. So, so this is about hand gestures, identification of hand gestures to understand the stroke. So let me, so now again, what we observed is that, like in those days, it was the rage to use handcrafted features. That means machine learning, core machine learning algorithms like SVM, and handcrafted features such as SIFT and SURF and HOG and all that, which was the vogue in computer vision at that time. So deep learning revolutionized the area of feature learning. Otherwise, like it was typical in machine learning to use handcrafted features like histogram of gradients, scale invariant feature transform, speeded up robust features, and many other features that were proposed in that time. So we observed that if you use an HOG SVM, the performance is not as good as a CNN. So those were the initial days of deep learning where we saw these things happen actually in our work. Then let me come to emotions. So like I have crossed about just about less than half an hour. I'm trying to time myself so that I can deliver maximum to you. So these are, this work is next to hand gestures. So here you see, this is about upper body uh, participating in understanding of the enactment of the dancer. So Navarasa, we say in Sanskrit, where rasa is conveying, maybe you can call that at a low level as emotion, but emotions in human beings in the Western world have been done with faces, not with the upper body or even sometimes the lower body participating in it. So if you see, the entire body of the dancer is trying to convey a certain idea, and that idea is a rasa. So the dancer is using her eyes, her face, her the position of the head, the position of the hands, the way the hands are interacting with each other, and the body, like the waist and the legs, they are all articulated. So, so when we say hand gestures, you say that we use fingers, we use articulated fingers to convey hand gestures. So here you see the entire body is articulate. Okay, it is having a certain, that entire shape of the body is conveying certain concept. And I don't know like what to say about rasa. Rasa is such a deep concept. I don't know what to actually say. I'm not an expert of this area, but I at least acknowledge that it is not emotion per se. It is something beyond emotion. So we have several navarasas in the Indian dance, and you can see these navarasas brilliantly in the sculptures of Indian temples. You just go to any Indian temple, a famous temple like a Konark or Khajuraho or the South Indian temples. You visit the temple in Madurai, or you go to Chidambaram, or you go to any temple of southern India, and you can see these navarasas on the sculptures. So the classic Raja Rani temple or the classic the temples of Orissa, they have the Shringara Rasa depicted using sculptures. So the Shringara Rasa, which is at the time when the dancer is decorating herself, maybe in preparation to meet her lover, or it is something very, very personal at Shringara Rasa. Then you have surprise or wonder, that is Adbhutam. Then you have the Raudra Rasa. So if you see the Durga, so the Durga, the sculptures of Durga in Bengal, they depict the Raudra Rasa. So fury, the anger. Then you have fear, Bhayanakam. Then you have, this is Vibhatsa. Okay. So then you have Hasya, the laughter rasa. Now these rasas are not they are not fixed in stone. So the individuality of the dancer comes into the picture. So the way the dancer interprets these navarasas is personal to her. So the variations in enactments they start coming in. I'll just show you a very classic variation. Then you have Karuna, then you have Shanta Rasa, and then the Veera Rasa. So there is Navarasas. We looked at 8 out of these 9 because the Shanta Rasa is very difficult to classify. So we just dropped that and we looked at the other 8 rasas. So we were trying to pose this rasa as emotion in one of our papers, and there was a very knowledgeable reviewer who said that it is not Navaras, it is not emotion, but it is upper body articulation. So we corrected ourselves. We understood something more than what we thought at that time. So we are going to look at dataset preparation and algorithms for classifying 8 Navarasas out of 9, and these are upper body articulation along with facial expressions. So the challenges, again, illumination variation, poor spatial resolution, makeup, strong makeup component is there because you have the upper body. So you'll have a lot of jewelry, dress, hairdo, all kinds of things they start entering in. And from one dance form to another dance form, like Mohiniyattam is not similar to Odissi, and Kathakali is unique, and you have Manipuri dance form. So you have so many dance forms of India, and but they all convey the same ideas. For example, some tale from Mahabharata or Ramayana is being conveyed by all these dance forms in their own personalized ways. So the thing that we observed here is there is ambiguity among enactments of the same Navarasa that I can show you. So can you see this bottom 2 figures here? These are enactments done by a professional dancer in Bhubaneswar who had actually given us a data set. So you see there is so much jewelry on the hand, there is so much makeup, then there are so much makeup on the face, and she's enacting the Hasya Navarasa in 2 ways. So if you train your machine learning algorithm to understand the Hasya Navarasa in a particular way, it will fail. Okay, you'll have to have a generalization capability of your algorithm to the individual traits of the dancer, of the individual taste of the dancer, or the way she tries to interpret these Navarasas. So let me show you one small video where you will get to see the difficulty of real world concept. So how to bring in computer vision here. So this is a classic enactment, and the dancer is a Russian dancer. She's not Indian. So this is a Karana. She is right now in a Karana position. Now she is enacting dynamic hand gestures. Her hands, fingers are moving. Now she goes into a Karana. This is a static posture, Nataraja posture. So you see, like, there were many enactments in this dance form. And initially when she started, the lighting was so bad that your algorithm will fail. Your computer vision algorithm has to really be robust to identify that Karana which she was trying to show in the beginning. So how did we approach this identification of Navarasas? We to systematically analyze and to approach the problem, we took it to the lab, captured data sets, both in color as well as in depth. So we understood that the texture or the color has some spurious components which should be removed. And to robustify our algorithms, we tried to capture depth maps. That means we understood that we need to remove the texture from the scene and only characterize the Navarasa or the upper body articulation by the depth profile where the texture is missing, only that structure remains. So we took 2 data sets one in the RGB with using Microsoft Kinect camera. And at that time, like there was Microsoft Kinect 1, then there was Xbox. Xbox had come very recently at that point of time. So it was able to give us high resolution depth as well as RGB. So here these depth maps are of size 512 cross 424 pixels, and we use some volunteers in our lab, and we enacted make those volunteers enact the navarasas. Now the volunteers are not dancers, okay? So they are normal students, PhD students, MS students. So how will it be good enough so that you can actually make your algorithm work in the real world? So we tried to see that. Many interesting things came in this journey with Aparna. Like I learned a lot of things. And by writing papers and by looking at the comments of the reviewers, we learned so many things. So like you see here, I hope Srija can identify the members of our lab. So you see there is Konkana here, there's Moshimi here, and so many other people. I think, I don't know whether Srija is here or not, I don't know. But there are so many of these Navarasas, there's 8 Navarasas being enacted by these students, normal students. And they were shown the Navarasa picture and they were asked to copy that. So that is how they have enacted. So along with these RGB pictures, we have these depth maps captured by the Kinect sensor. So, and this was a data set captured by Aparna by using professional dancers. So here the background is cluttered, background is not plain. The dancer is wearing jewelry. She is in proper costume, and she's right now in the Odissi dance form costume, and she's showing all these navarasas. So let me show you a video where you can spot some of these navarasas. So this is the Sringara Navarasa, the first one. There she goes into the Karana. This is another Navarasa. This is another Navarasa. This is the Shanta Navarasa. He's trying to enact the Trinetra of Shiva. This is the Adbhuta Navarasa. So the video goes on, and the video is actually enacting this shloka. So if you see this shloka, it is something that describes the emotion of Parvati when she is being, she is trying to visualize Shiva. So there are so many things in this like shloka, and I have tried to show some of the navarasas from the video by splitting the video into frames. So you can actually see these navrasas in the video. So the first navrasa that I told you was the Shringara navrasa. So that is this part of the shloka. Okay. Then the Vibhatsa, then the Adbhuta, surprise. Then this is Bhayanaka, fear. And then this is Hasya, and Karuna and Shanta. So if you see the entire video, slow it down and see, you can spot these navrasas in a real world concept. So can we build algorithms to identify these navrasas? So that was our goal. And we started off with both RGB as well as depth map. And then we moved on to the real world dataset. So we have 3 datasets here. And we started with a very basic 2 convolutional layer. Then we increased the convolutional layers to 3 and 4, again using pre-training and then data augmentation. So those were the standard tricks being used in those times. I don't know, today you people are using deep learning, so you can teach me some new tricks, and we can see like how this performance can be improved. So again, we were comparing, at that time we were comparing with all these standard machine learning techniques, HOG, SVM, SIFT, SURF, BRISC, LBP, SVM. So initially we got some low accuracies, then slowly we tried to use deep learning, and we saw the algorithms, they started to perform better than these handcrafted features. And so this is something interesting, that if you understand what is happening inside the network and you try to plot the output of some of the filters, then you see that the filters are somehow responding in the CNN, they are somehow responding to the salient parts of the dancer in conveying a particular emotion. So, and then we did an ablation analysis. That means we varied the number of convolutional layers and then started checking how the accuracies they behave. And so initially the 2-layer convolutional network, then 3 convolutional and 4 convolutional network. And we started to also look at, now we are looking at grayscale and color. So we converted the color images into grayscale, and we fed the input image. If you see here, the input image is a grayscale image, and again it is of size just 32 cross 32 pixels. So, and here, for example, this is a color image that we are feeding into the network. So then initially that was grayscale, then augmentation of grayscale data, depth, and the real world. So if you augmented the dataset, the performance used to go high. So that was the standard thing that was happening at that time. And then we augmented the color, and we saw the performance go a little bit more higher. And then the effect of using pre-training, that is using CIFAR or other types of datasets to pre-train. And slowly we saw that we could reach very good accuracies. And for the real world case, you see, we are now able to reach 94%, which is pretty impressive compared to the variability and the ambiguities in the dataset. It is actual data of dance. So trying to conclude some of the work that Aparna did. So initial 2 papers that she had published, so we tried to show you here, and we proposed many data sets, and we tried to, like, for the first time in, I hope, we are the first people to propose these data sets and to work on these data sets. So what can we do in the future? The future is wide open. This problem we have just barely scratched. And for young researchers, those who want to take up this as a challenging machine learning problem, it is like a very rich area. You have so many things in this. We started exploring static hand gestures, then there are dynamic hand gestures. In fact, I was taught by students many times. One day a student comes into my room and she says that I'm an MS student from some ocean engineering, but I learned dance and I can teach you dynamic hand gestures. And she showed me the Brahmara hand gesture, that is with her fingers, she showed me the motion of a bee on a flower. and it was so beautiful. So I just thought, like, can I just take a data set? So we were just very curious people at that point of time. Whenever there used to be a Speak Mac a concert, we used to go with our cameras, and all the lab members used to contribute. They used to work like a team, and we did so much work in those times. It were exciting times, and like I really miss those times, and I cherish the times I spent with Aparna. So very very nice work that was done here. And I would like to mention Shankar Ganesh, who contributed a lot to Aparna's work, and in collection of data sets and other things. He was a member of our lab. So, like as I said, like static hand gestures, dynamic hand gestures, static body postures or karanas, adavus are dynamic body postures. Then you have navarasas. Navarasas are having so much variability. So there are so many challenges like severe illumination variations, occlusions. What happens when there are multiple dancers on the stage? You will have occlusions. One dancer going in front of the other dancer, and someone coming closer to the camera, someone going away from the camera. How do you accommodate for those variations? So this is a very very rich problem that we just barely scratch the surface. So some of our publications, and we are still in the process of trying to publish our work in good places. And the
Right.
Navarata work was published in PR, and the Nitya Bodha work, that is the hand gestures, was in signal processing image communication. You see some of the authors here, they are actually BTech students. They came for an internship to my lab. So I included their names as authors in the paper, and I made sure that they got their credit because they contributed to the data sets and to the work. And Konkana has also contributed, and we have a book chapter, many conference papers. So this was our work. And if you have any questions, I would like to answer. And some of our works are very general, so you can apply it to the Western data sets of hand gesture recognition. So this is something that we did, published in ICCV workshop, and so it can be applied to Indian classical dance. It can be applied to